This is a transformer. This one is the primary winding and this is the secondary winding, and this part is the core of the transformer, which is of magnetic material. This one has a very high permeability, much higher than air, so it allows flux to flow through it easily, and that is the reluctance is much less for magnetic flux. Reluctance is equivalent to resistance for current, so less resistance allows more current. Conductor has less resistance. Similarly, a magnetic material with high permeability has uh, less reluctance, so flux can pass through that easily, through the material easily. So if in this primary winding an AC voltage source is connected, then let's say for one particular instant we have a current going that way. Now this current, since it's an AC, it will be changing. So I'm just looking at a particular instant. So this current is flowing that way, coming back, and then coming back. So if I apply right hand grip rule in this part of the core, I grab it with my right hand, and in the so that the finger points to the direction of the current, then I can see that the flux that it creates is going upwards. And since this material has a very high permeability, most of the flux will be confined here. It will come back like that. There will be some leakage flux through air as well, but we can neglect it since the permeability is very high. Now this is an AC current, so the flux is also changing, and this changing magnetic flux is also passing through this coil. Nothing is connected here, maybe a load is connected there, some sort of load, but there is no source there. But this is a changing magnetic field that is passing through these coils, this winding. So what happens is, because of this changing magnetic field, from Faraday's law of induction we know that it will induce a voltage here, and we also know from Lenz's law that the voltage will be as such so that it opposes the cause, and the cause is a increasing flux downwards. So it will try to produce a flux upwards so that it can reduce the increase of flux, reduce the downward flux. So in order to have a flux going upwards, if we again apply right hand grip rule in this part by grabbing this side of the core by right hand, we can see that the thumb will now has to point towards the direction of the flux, so thumb will be upwards. So if we grab the the core now, we can see that the current will go this way. So it has to come this way and this way. So the current is as such, it is producing a flux upwards so that it's trying to oppose the downwards flux, which is the cause of the current in the first place. So this is how there will be an induced voltage here, which will result in a current. Now this is the principle of a transformer. We can see that there is no electrical connection between winding 1, this is primary, this is called primary, and this is secondary. There is no electric connection, but there is this magnetic flux that is creating a voltage on the other side. Now the voltage has a voltage in the primary and voltage in the secondary. There is a relation which is something like this: V1 over V2. The secondary voltage is depending on the number of turns, because we know from Faraday's law that the induced EMF is negative and then n d phi over dt. So this n is the number of turns, which is here. So the ratio of the voltages will be n1 over n2, and also the power has to be the same both the sides. So basically V1 is equal to V2 I2, and so I1 over I2 will become N2 over N1, just like that. So basically, these are the two ratios that is true for a transformer. And also this voltage in the primary has to be an AC. because if there is a DC voltage, it will still produce a flux, but that flux will be a constant flux. So when the flux is not changing on the secondary, there will be no induced voltage, since d phi over dt will be 0. So there will be no induced voltage. So the primary voltage has to be an AC. This transformer is very useful. Now we can see that from this ratio, we can we can use the transformer to increase the voltage from one side to another side, which is used in a power generation plant. So power is generated at a certain voltage is generated, and that voltage before sending to the transmission line is stepped up to a large amount, and that is used by a step up transformer. So if the primary winding, just let's say, just for example, if it has say 10 turns, just an arbitrary value, and if this one has 100 turns, then the voltage, if this voltage is say something say 100 volt, then the voltage on the other side will be 1000 volts, because it will be 10 times more. This is how it is. And similarly, in the receiving end of the transmission line, the voltage is again step down. So then the voltage transformer is used, which is a step down transformer. So step down transformer will have N2 less than N1, so that we can have a stepped down voltage on the secondary. And step up transformer will have to have N2 greater than N1, so that we can step up the voltage. That's how it works. So this is very in short the principle of a transformer, and I will leave this video here.